Okay, let's explore this foiling process we just saw a little more in depth and look at a couple different examples. We saw 2 examples of foiling already. 5.5 is really, it's called special cases of multiplication of polynomials. There's nothing too special about it, but we're still going to end up foiling. So a couple more examples, something that looks like, right, this is considered a special type of multiplication, right? But that doesn't mean you do anything differently. This is a binomial times a binomial. Your brain should immediately say, I'm going to FOIL this together. So, right, distribute the x, distribute the 3, x times x, x times negative 3, that'd be a negative 3x. Okay. All right, now take the 3 and distribute it, 3 times x, and 3 times negative 3, negative 9. All right, so there's nothing that changed in this foiling process. Why this is considered special is because these 2 middle terms in this case, right, negative 3x and positive 3x, they cancel out. We end up with x squared minus 9. Right, that did not change our process at all. It was just a nice situation where those middle terms canceled out. And when those middle terms cancel out, right, this has a name. It's called a difference of squares. And we'll come back to that and revisit that idea in chapter 6. But for now, right, it should not mean that, or to you when you see this problem, you shouldn't think I need to do something different. Follow through with foiling. Right? See what you can do with the middle terms, and if they cancel out, great. If not, just combine them like normal. So nothing really new here. This just has a fancy name to it that we'll explore in chapter 6. Right? Another fancy, other special type of multiplication would be if I had a situation where I took a binomial to a power. Right? This one is very common to make a mistake on because people just get a little, I don't know, efficiency happy, and they're like, oh, this is easy. I know how to square 2a. Right? And lots of people will say, yeah, 2a squared, that's 4a squared. Right? And I know what 5 squared is, that's 25. And lots of people will write this, 4a squared plus 25. And if you do write that, you're almost right. Right? You have 2 out of the 3 pieces to the puzzle, but this is not the correct answer. You cannot just square both pieces. That's not all that is happening here. So when you ever have a polynomial raised to a power, you have to be extra careful. And I suggest, right, until we get the hang of it, writing it out and just foiling. Right? It seems tedious, and it should be tedious because we're going to have to delve a lot deeper into it into chapter 6. So whenever you see a power, a polynomial raised to a power, just split it up and say, I know how to FOIL this. 2a times 2a would be 4a squared. 2a times 5, well, that's easy, that's a 10a. Distribute the 5, 5 times 2a, another 10a. And 5 times 5, a 25. Did anything change here? No, we FOILed like normal. Right, these 2 middle terms grouped together, they add up to positive 20a, and we're done. So the only thing here I have is a warning. When you have a polynomial raised to a power, do not try to shortcut this. You're going to make a mistake and forget the middle term. Right? There is a 4a squared, you're right. There is a 25, you're right, but you're going to miss this middle term if you do not FOIL it out. So I suggest foiling in this case. All right, those are 2 special cases of multiplication in 5.5, but again, just FOIL. I'll give you one last example, because all we've done so far in terms of multiply polynomials together is just do binomials. That's obviously not where this ends, but it is a very common place to stop, because if you can do binomials, you can also do trinomials, or any bigger polynomial multiplied together. It just requires more steps. So I'll do one example where we multiply, let's say, 3x plus 2 times x x squared minus 4x plus 5. So now we have a binomial times a trinomial. Right? There's no acronym for this. The acronym FOIL only applies to binomial by binomial. It explains all four, or spells out all four pieces of multiplication you need to do. For anything bigger than a binomial times a binomial, there's no acronym. You just get in the idea of this distribution. I'm going to take this 3x and distribute it to all the terms over here. So there's 3 pieces of multiplication I need to do. Now I'm going to take the 2 and distribute it to all the pieces over here as well. So it's more or less a double distribution, as how, like I characterized it before. So nothing new, just we can't talk about it as FOIL. 3x times x squared, right? Add the exponents, that'll be 3x to the third. 3x times negative 4x will be negative 12x squared. 3x times 5, that's a positive 15x. 2, now distribute the 2. 2 times x squared would be a positive 2x squared. 2 times negative 4x would be negative 8x. And 2 times 5 would be 10. Okay, so we have a 2-term expression times a 3-term expression. 2 times 3 is 6. That would mean I better have 6 terms down here, because I did 6 pieces of multiplication. And now just group together our like terms. Right? This x to the third is by itself, so nothing to do here. I do have negative 12x squared and positive 2x squared. Negative 12 and positive 2 should be negative 10. And I have positive 15x and negative 8x. Those should group together to be a positive 7x. And then a plus 10, that constant term is by itself, and now we're done. So, and is it more difficult to multiply higher degree polynomials together? No. It's just more possible to make a mistake because you have more pieces of multiplication to do, but there's nothing new or more difficult about it. All right, so that's the end of 5.5.